If you've clicked on this video, then chances are you're struggling with A-level physics, and if that is the case, then this video should help you out. I just want to start this video by letting you know that I got a U in my first ever topic test in A-level physics in year 12, and I get DMs from students that look like this all the time. So someone here messaged and said, okay, like, I need help with the whole of physics. The shit is not like GCSE at all. From an 8 to a D/E, I need help, please. So in this video, I'm going to hopefully help you out. Why should you listen to me? So my name is Khalid. I'm an Imperial College London graduate. I studied chemical engineering there. And for my A-levels, I did maths, further maths, chemistry and physics. I got 2 A stars and 2 A's. And I got an A in A-level physics because I made a lot of mistakes in my A-level physics journey. And hopefully in this video, I'll give you some useful advice that will definitely help you to improve your result and at least get an A at A-level, but hopefully an A star if you put in the work and if you actually want that result for yourself. So I'm going to talk through a 4-step process in this video. These are the 4 steps you need to take if you want to actually achieve that result. So first of all, you need to develop an initial understanding of the topic, then deepen your understanding through foundational problems. Third, build long-term revision resources with Anki. And then 4, you need to grind questions from PMT and Isaac Physics and other resources out there. So I'm going to walk through each of these 4 steps in detail in the next few minutes, but hopefully that makes sense. Before we get to those 4 points, I want to talk about a prerequisite, which is time management, basically. So, like, how should you manage your time when you're doing A-level physics, and how should that sort of work? So the way I think about time management, and if I were you, this is the way I would think about it as well, is you want to split your time between understanding and application. Okay. This is very important. So when you're studying physics, there's going to be some time that you spend trying to understand the topic, like reading, watching videos, and absorbing information, right? And that all kind of falls under understanding. So let's write this down. So you're going to watch videos, you're going to read some notes and textbooks, perhaps, right? You might even research online, right? And you might even use ChatGPT as well to sort of help you to understand some concepts. And then application is basically going to be like practically and like actively engaging with the subject, right? So this is going to be like solving questions, answering like review questions. So these can be like flashcard review questions, or they could be like just regular review questions, exam questions, etc. Right? So pretty much understanding is all about absorbing and understanding the information first, and then application is all about applying your knowledge to do questions or to review your content or your knowledge that you've learned beforehand. When it comes to understanding, this should take approximately, in my personal opinion, about 10 to 30% of your total time. Okay, that's key. And for application, this should take about 70 to 90% of your total time. Okay. That's very important. The reason why you want to do this is because you want to heavily skew your whole studying process towards application and towards actually engaging and doing questions. This is so important because I think the main mistake that people make when they study A-level physics, and the main mistake that I made in my journey when I was studying A-level physics, is I was spending way too much time reading and understanding the material instead of actually applying my knowledge to do questions, right? So it's really important that you spend most of your time on application. They're actually doing questions, solving equations, practicing applying your knowledge, or reviewing your content through active recall and spaced repetition and just answering review questions, etc. So hopefully that makes sense. That is the overall time split that we need to keep in mind. You want to spend 10 to 30% of your time on understanding and about 70 to 90% of your time on application. Now that's the first phase in terms of like what should you actually spend in your like hours when you're studying physics. For example, let's say you have 2 hours to study physics, you'd kind of split your time between these 2 activities in these sorts of proportions. Another thing you have to keep in mind is like, how should I overall like manage my time when it comes to physics? I think the way you want to do this is first of all, figure out how many physics lessons per week that you have, right? That's the first thing you want to do. Like, how many hours of physics lessons do I have per week? So let's write hours. So you want to figure out how many hours per week you spend studying physics. And then what you want to do is match studying hours outside of school with those in school. Okay? This is really important. What you want to do is match the hours that you spend studying in lesson to the amount of independent hours that you spend outside of school, and I would say this is the bare minimum that you should be spending on physics. Okay, let me show you an example to just clarify this if you're not getting what I'm saying here. So let's say, for example, in school we have 4 hours of physics lessons per week. All right, this is average for like most schools, right? 4 hours of physics lessons per week. Okay. This means that you want to spend 4 hours at least. So at least, say greater than or equal to 4 hours of independent physics study per week. Okay. And this actually includes the time for homework as well. So these 4 hours that you're spending should include the time for homework. So you're spending 4 hours of time outside of school per week to actually do your independent physics study. This includes your time for homework, and this should be the bare minimum that you're spending. Okay, so hopefully that makes sense. And with this time, you can distribute it between your free periods after school and on weekends, depending on your schedule, depending on when you're free, and depending on how you like to study and how you like to do things. Okay, so hopefully that makes sense. And it's really important that you do a minimum of 4 hours of independent study per week. Don't just go to lesson and just do your homework and that's it. There's a lot of stuff that you can be doing in order to study, and I think 4 hours is the absolute bare minimum. You can do more if you want to work hard and if you want to guarantee that A star, but I would say at the bare minimum, if you just want to get an A, then just do 4 hours of independent study per week. Usually, let's say homework takes you like, let's say for example, homework takes you 1 or 2 hours per week. So let's say homework takes 1 to 2 hours per week. This leaves you another 1 to 2 hours, or let's say 2 hours, 2 to 3 hours for independent study, right? And in this time, right, in the independent study time, okay, this is when you can do more of the questions and you can do more of the like 4-step process, right, that I'm going to mention in this video, okay? So in the independent study time that you have, the 2 or 3 hours left over or more for independent study outside of your homework, that's when you can apply the 4-step process that I'm going to talk about in this video to actually get that stuff done. All right, so hopefully that makes sense. That's kind of what you want to do for time management. Just to recap, you want to split your time between understanding and application, making sure that you heavily prioritize application over understanding in terms of the time split, right? You still want to get a thorough understanding of the material, right? Don't rush that. That's why I'm giving you a bit of flexibility here to go from 10 to 30%. But you can see the vast majority of your time you want to spend on application, actually doing questions, solving equations, or actively retrieving information from your mind. Then another thing you want to do when it comes to time management is figure out like how many hours per week do I want to study for physics, right? So the way you want to do this is start by matching the amount of hours you do in school and outside of school. That's going to be your bare minimum. And then if you're struggling to actually achieve the results that you want, or you want to do better and get faster results and better results, then you just need to do more hours per week outside of school. It's as simple as that when it comes to time management. So hopefully that makes sense. And that's pretty much it for this section. Let's get on to the first step of the 4-step process. So the first step of the 4-step process is to develop an initial understanding of the topic. Now, I've given you these 3 resources here, and I think if I were to go back and redo my A-levels, these would be the 3 resources that I would use. First of all, we have textbooks, of course, right? Now, the reason why I like the textbooks is because they are exam board approved. So the exam boards have kind of looked over the content and said that, okay, this largely covers all the material that we need you to know for our exams, right? So textbooks, I think, are a good place to start. I think the explanations are pretty clear. And what you want to do is there's quite a few textbooks for each exam board. So basically scan through them all to figure out which one you like the style of best. I personally prefer like the Oxford University textbooks for AQA physics. So if you're doing AQA physics, I think this is a good book for you to use. My personal opinion, you might prefer the CGP one, you might prefer the Hodder one. It doesn't really matter. Just pick one that you find, okay, I like the explanations from this book, and go with that, right? So hopefully that makes sense. I do think textbooks are a good place to start when it comes to explanations. I don't think you should learn from like revision notes, like PMT notes or Save My Exam notes, because I don't think they give you a really good and deep understanding of the actual physics behind the concepts. They kind of just give you a summary, and that's the whole point in it, because it's notes for a reason. So hopefully that makes sense. Textbooks, I think, is a good place to start from. Another thing you want to use, if possible, is YouTube. So I've got a YouTuber here. So YouTube, I think, is a pretty good resource as well. There's lots of YouTubers out there that, you know, will make videos explaining the concepts. So you can use YouTube as well. I think I used YouTube when I was in my A-levels too. So use YouTube if you can. There's people like Z Physics, A-Level Physics Online. They have some good videos out there. So check out their videos and see if they help. And another resource, which is a bit, I would say, controversial, but I think is extremely helpful, is ChatGPT. So some people are worried that ChatGPT is going to give them the like wrong information. I would say you should use ChatGPT to just clarify your understanding of something. I think ChatGPT does a good job of, you know, teaching material up to university level. Obviously, beyond university level, it kind of, you know, it's not really that helpful anymore. But I think up to university level, it does a good job. So I think it would help you to clarify your understanding of specific concepts. For example, if you have some confusion about something, you could explain your thought process to ChatGPT, and it could sort of clarify it for you. Or it could reword specific like phrases or terminology from the textbooks or the YouTube videos to make it more coherent for yourself. So I think ChatGPT is a very good resource to use when it comes to digesting and understanding the information to start off with. Okay, so hopefully that makes sense. I would personally go with these 3 resources as my base. And then I would use notes to sort of summarize the information that I've learned, like for example using the PMT notes and the Save My Exam notes to sort of summarize all the information that I've learned from these main resources. Another thing that's very important when it comes to understanding the material is to make sure that you understand the material in line with the specification. So you never want to study the information away from the specification, if that makes sense. As in, like, you want to make sure that everything you're studying is connected to the specification somehow, and you always have the specification top of mind. So to be honest with you, this should be saved like in your Google Chrome somewhere, or like on your browser or whatever. Like, you should have this favorited like somewhere so you can always access it as quick as possible. This is the most important tool to have, your specification. All right. If you're not sure what I'm talking about, just search AQA A-Level Physics or whatever your exam board is, specification, and have a look at that PDF document. It's going to be like a massive 100-page document which tells you everything you need to know in terms of content for your exams. All right. So with this is really important. When you're studying from the textbooks, YouTube and ChatGPT, you always want to come back and just clarify your understanding by looking at the specification here, right? So the good thing about these textbooks, by the way, the ones that are exam board approved, you can see here, it says AQA approved. I don't know if you can see that there, but up there it says AQA approved. These exam board approved textbooks they match the specification. So they're built to basically match the specification, and so you can study alongside the specification, which is really helpful. Some YouTubers won't do this for you, so you have to keep that in mind, but some of them will. So I would say use the YouTubers that are exam board specific. Of course, ChatGPT is not really exam board specific, but you can do some little quick tricks with ChatGPT. For example, you can copy and paste this information here just to say, okay, this is what I need to know. Can you clarify this one thing for me here and there? All right. So hopefully that makes sense. The specification is really important to help you understand the material, and you want to make sure that you're using this alongside your resources. Another thing that you want to do as well when you've finished, let's say you finished reading the textbook and you've digested and you've absorbed the information from the textbook, you want to clarify your understanding by reading the specification. So, for example, in this book, this specification point, 3.2.1, is covered in like 2 or 3 pages from this textbook. Okay, so this is about 2 or 3 pages. Okay, so from these 2 or 3 pages, once you finish reading and digesting the information and you've clarified your understanding by researching online with YouTube and ChatGPT, and you've researched and you really understood all the material from the textbook, the way you can clarify your understanding is to read through the specification points here and just to check it off if you've understood the material. All right, that's how you want to do things. Okay, so you can use this not only as a resource to identify what you need to know, but also as a way for you to check your understanding once you've finished digesting the information from the textbooks, YouTube, and ChatGPT. All right, so hopefully that makes sense there. So let's keep going. So I think that's basically it for the first phase when it comes to understanding the material. One thing I want to let you know is that when you're going through this step 1, you're not really going to have like a deep understanding of the material. That's something that's really important. Yes, you might have some sort of good understanding of the material, but it's not really going to be a very deep understanding. It's going to be quite superficial, to be honest with you, especially for those like more complicated topics. This topic here about the constituents of the atom is quite basic, but for some other complicated topics, if you just read through the textbooks and YouTube and ChatGPT, you're not really going to have a deep understanding of the material. You're just going to have a basic, decent understanding of the material. And what you want to do after this phase is then deepen your understanding through basic problems, which is step 2 of the process, right? It's quite basic and quite simple. But you want to basically do as many questions as you possibly can to really understand all of the information that you just read about from the specification. All right. So you can see there's a bunch of questions here. You got application and factor recall questions, and I promise you, if you did this for every single specification point in your A-Level Physics subject, if you did all these questions for every single specification point, I promise you'd have a very good understanding of all the points, and you'd basically really understand the material. Okay, so that's really important. It's very important that you do these sorts of questions to really understand the material. One more thing I want to say actually for phase 1, when it comes to developing an initial understanding of the topic, is don't take notes. This is a point that might be a bit controversial, I don't know. But I don't think taking notes is a very helpful thing to do when you're going through step 1. Because if you're anything like me, you're going to basically transcribe the information from the textbook as opposed to digesting the information. So what you want to do is read and absorb the information, and then don't take notes, because that's going to waste your time. It's going to take away your attention from actually understanding the material. So hopefully that makes sense there. So Step 2, yeah. So once you've done these basic questions, right, you're going to be practicing your calculation skills. You're also going to be practicing your fact recall. For example, these questions here about fact recall will technically be your notes because they're going to get you to explain the concepts from your memory, right? So instead of you taking notes on the information, you can just do these fact recall questions and these will act as your notes in that sense, okay? And there's lots of these sorts of questions here. So for example, here we've got some fact recall questions. Even here we've got some fact recall questions. And also here we've got some fact recall questions as well. So just by answering these questions, you're technically taking notes, but it's in a more active way, and you're not really going to waste your time you know, splitting your attention in this first phase. So don't take any notes. Trust me, don't take any notes. Just really when you're doing this step 1, try to understand the material by reading, going researching online, and really researching and asking as many questions as you possibly can to deepen your understanding. Then once you're done with that, in this phase, you are going to technically get your note-taking experience through these sorts of fact recall questions, and you're also going to get calculation and application practice here. Okay, so hopefully that makes sense there. So that's step 2. Let's look at step 3. So once you finish with step 2, step 3 is about building long-term revision resources with Anki. Okay, so this is one thing that I know that 99% of you guys that are watching this video right now are not doing. And I know that it's a very time-consuming, difficult, annoying, mundane, boring thing to do. I understand that completely. But I promise you, if you did this step, then by the time you were in year 13 in the summer or Easter holiday, you wouldn't be stressing about revising AS content or year 13 content. You would just naturally know 90% of everything you've learned since the start of year 12. And that is the power of Anki. The power of Anki is that you can have a 90% retention of all material you've learned since the start of year 12. If you use it consistently, if you use it properly and appropriately. Alright? So this is why I think Anki is such a powerful tool. And I wish I used it when I was in my A-levels. Because when I was in my A-levels, I used the paper flashcards. And I wasn't doing any spaced retrieval. Right? So if you don't know about this, by the way, spaced retrieval practice is the best way for you to remember information long term. If you're trying to remember information long term, it doesn't matter what kind of information it is, right? Whether it's a chess opening or a language or A-level content, spaced retrieval practice, spacing out the memory of this specific sequence or this specific information is the best way for you to strengthen your memory because it combats the natural forgetting process that happens, right? If you're interested, you can have a look online about forgetting curve and why Anki works, etc. But all I'm trying to say is that this resource is so powerful, and I wish I used it when I was in my A-levels. When I used that at Imperial for like the first year of uni, I was getting like 90% in like a lot of my tests, like a lot of my end of year exams and also my spring exams. So it's a really powerful resource, and I strongly advise everyone who's doing A-level physics to use it. But I already know that 99% of you guys that are watching this are not going to do it anyways, but I'm still going to tell you guys to do it because it's very powerful and it's because it's going to help you. One thing you have to realize, by the way, with Anki is, number one, you want to build the flashcards yourself as much as possible, because when you're building your flashcards, you are consolidating the information yourself in your own mind. I know a lot of people sell flashcards, and I know you can buy, and I know you can like find free like Anki decks online. The problem with going and using other people's decks is you're not gonna consolidate, and your memory of that information is basically non-existent, and so you're gonna have to memorize their answers to the flashcards when you could have spent that time making your own flashcards and consolidated it yourself and improved your memory long term. So yes, making your flashcards is longer, right? It's going to take like a longer time in it, like in the short term. But long term, it's going to be way more effective and way more powerful. So how do you learn how to use Anki? If you're not sure how to use Anki, these are the 3 resources that I recommend that you use to get started. So first is Anking. He's a YouTuber who makes some content on Anki. His videos are really good. I use them when I was getting started with Anki, so I think you should use them as well. Once you're a bit more advanced and you've kind of done with using the Anking, I think the Anki subreddit is very helpful. So you can check for people's questions, and you can have a look at some tutorials and some quite interesting articles about how Anki works and new features and updates to Anki, etc. And if you want a more in-depth guide built by the actual developers of Anki, you can have a look at the Anki manual. So just search these 3 resources on Google, and you should be able to find them, and you should be able to use them to get the results you want with Anki. So when it comes to like more A-level specific advice for Anki, a key point that I have is you want to look at exam questions to understand how each specification point is tested before you make flashcards. For example, let's say I was going to make flashcards on this specific section of this specification point 3.2.1.1, stable and unstable nuclei. So this is all about the strong nuclear force, its role in keeping the nucleus stable, short range attraction up to approximately 3 femtometers, very short range repulsion closer than approximately 0.5 femtometers. So let's say, for example, I wanted to make a flashcard on this. I'm assuming, if you're at this stage, that, let's assume, by the way, for this, right, for this point, that we've done step 1 and step 2. So we've done step 1, we've actually went to the textbooks, we've learned about the strong nuclear force, we've watched some YouTube videos on that, we've clarified our understanding with ChatGPT, and we also read the specification point to just double check that we've understood the material at a superficial level. Then, once we did that, we did lots of questions on the strong nuclear force, applying our knowledge, and also doing fact recall questions. So at this point, right, before we make our flashcards, we have a very good understanding of all this information here. Does that make sense? We have a very solid understanding of this information here, and so it's easy for us to make flashcards, etc. Right? So what we want to do is have a look at the exam questions on that topic to figure out how they test that knowledge. For example, look at this question here. The strong nuclear force is responsible for keeping the protons and neutrons bound in a nucleus. Describe how the strong nuclear force between two nucleons varies with the separation of the nucleons, quoting suitable values for separations. What you want to do is not only search for this one question here, which talks about describing how the strong nuclear force works, basically, but you also want to check all other questions related to strong nuclear force in each pack of exam questions that you'll find on PMT or any other like exam question bank. All right. So when you do this, you will basically figure out like how they test this knowledge and also the sorts of answers they're looking for when you're answering this question. For example, here it's a 3-mark question. Of course, you get 1 mark for talking about what happens when is a strong nuclear force repulsive, when is it attractive, and also what happens when we go beyond 3 femtometers, right? And you can also see here that it says can get marks from a labeled graph as well, right? So you can use the mark scheme and the sorts of questions that get asked to inform you of what sorts of information needs to be turned into flashcards. So let's say you did that and you kind of understood, okay, cool, I need to know this, I need to know that. Then when you go to making flashcards, which I think you should use PMT notes, or you should use some kind of summarized notes to make your flashcards, in my opinion. You can use the textbooks to make your flashcards, but I think using summarized notes like PMT notes or like Save My Exams notes will be more effective because they've summarized the information, they're kind of just giving you the key points that you need to know. All right. So you can use this to make your flashcards, and you can design your flashcard, right? So you can use information to make a flashcard to satisfy this, and you can make your flashcard to basically exactly satisfy the mark scheme answer, right? So for example, let's say I wanted to make a flashcard to remember this knowledge. How would I structure my flashcard? I'd probably write something like this. Explain everything you know about the strong nuclear force. Include the following in your answer. So a graph showing the force between the nucleons against the separation of the against the separation. And you can also say add appropriate units to the x and y axis and indicate key values on the graph. And also describe an explanation of the concept in your own words, describing the behavior of the graph. So in my answer to this flashcard, I think I want to reproduce this whole graph because I might find another question later down the line that asks me to interpret or to draw the graph from scratch. So I want to practice drawing this graph. And then I also want to practice explaining the concepts and explaining the graph and how they link together. All right. So I want to do both of those things in my flashcard. And if I do that, and I'm able to retrieve this flashcard for a long period of time over the course of 2 years in A-levels, by the time I come to an exam question and I see this when I'm doing my questions in the next phase, or when I do a question in the final exam, I'll just instinctively and automatically generate the right response that will get me the marks. So hopefully that makes sense. You want to produce a flashcard in a way to get you the marks from the mark scheme, but before you make your flashcards, I think looking at the sorts of questions that get asked and then basing your flashcards on that is the way to go, in my opinion, right? Instead of you sort of just turning all the information that's available into flashcards, you're kind of zoning in on the most important information and turning that stuff into flashcards. So hopefully this is making sense. Hopefully I'm not confusing you too much. Very simply, look at the exam questions first, identify from the exam questions how they're testing this knowledge, and then once you understand that and you understand what is the stuff that gets marked, right? What is the thing that will get you the marks, then you can use that to inform your flashcard creation process to make it more effective. So hopefully this is making sense so far. That is the third phase. You want to build your long-term revision resources with Anki. Once you build your flashcards, you obviously need to go through them. My advice for this would be allocate 1 hour per day every single day for the next 2 years to go through Anki. And do it at the end of the day. Do it as the last thing you do before you go to bed or before you wrap up for the day. So creating Anki flashcards and also going through Anki flashcards isn't a very time consuming and energy consuming like process. Like you can do this when you're tired. You can do this like it doesn't really require too much brain power to actually go through and create flashcards and make the flashcards. At least for me personally, that's not the case. Maybe for you, it's quite hard for you to make flashcards. Maybe you want to do that a bit earlier. But in my opinion, I think making flashcards isn't that hard. So I would say do this as the last thing you do before you end the day, right? So you want to spend about half an hour per day to create flashcards on whatever you did in lesson for the day. For example, let's say you have one physics lesson and one chemistry lesson. Maybe each lesson will take about 20 minutes to make the flashcards, right? So maybe 20 minutes for one lesson, 20 minutes for another lesson to make the flashcards for that lesson. Then you have another 20 minutes left over to review all the flashcards that you've done that are due and the ones that you just created as well. So that you can just stay on top and you basically have no cards that are left over, right? So if you can just structure and just give yourself an hour a day after school to go through your flashcards and to create your flashcards, I think that would be a very, very good idea. And it would help you to stay on top of your Anki long term. Of course, it's going to be a 2-year commitment, an hour a day after school, every single day. But I think it's worth it. If you want to remember 90% of your information that you've learned since the start of year 12, and all you have to do is put in an hour a day, would you be willing to take that trade? I think everyone would be willing to take that trade, but most people are not cognizant of the fact that they're gonna, retain 90% of their information over 2 years if they did this consistently, right? But now that you've watched this video, you understand that you're gonna retain 90% of the information that you've learned over the 2 years if you use this consistently for an hour a day. So just have that commitment, so that way you save so much time, in the long run. I'm telling you right now, yeah. Basically, I have a few students in it on a coaching program that I sort of run, and one of my students, he has been doing Anki consistently since September of 2024. Right now I'm recording this video in February of 2025. And he just remembers all of the information that he's covered since the start of the year. So for example, when his teachers ask him a starter on some random topic they did like 2 months ago, he just knows the definition, exactly how the mark scheme wants it instantly. Because he was consistently going through his Anki flashcards day in, day out. So that's what you want to do if you want that result. If you want that result, if you want to remember all the information that you've learned long term, you need to put in the work when it comes to Anki. Another thing you have to realize is that you're not going to see the results in 1 week or 2 weeks. You're going to see the results in 3 to 6 months from now. That's what you have to realize. It's a long-term investment. And I think the way you should think about Anki is that it should be for the year 13 exams. The reason why you're building it now is to help you when you're going to the year 13 exams, not for this topic test that is coming up right now. It's still going to help at the topic test that's coming up right now, but the main benefit you'll see is that when you're in year 13 and you're preparing for your final exams, you're going to be like, thank God I did these Anki flashcards consistently. Okay, so hopefully that makes sense. So the final point, the final thing you need to do after you've done the Anki stuff and after you've done phase 1, phase 2, phase 3 is just simply to grind questions. It's simply to grind questions. Now, and the resources that you can use for this should be PMT or Isaac Physics. So what should you do when it comes to this? You should do questions from both the old spec and the new spec. Don't just focus on the new spec, do questions from both. Do as many questions as you can. I would say stick to your exam board specification first and do old spec and new spec before you move on to another exam board. For example, focus on AQA, old spec and new spec if you're doing AQA physics before you go into OCR and EdXL, etc. How do you do these sorts of questions and how do you do these sorts of booklets? For PMT, Physics and Math Tutor, by the way, if you don't know what that means, when it comes to doing the questions from Physics and Math Tutor, just do the questions, of course, in order. If you see a question that you know how to solve or you've answered it before and it's kind of repetitive and you know how to solve it and there's no point of trying it, then just skip it, right? For example, let's say you've done a definition question, define an isotope. You've seen that question already. You've answered it. You got the full marks. You see that question and come again later on in the booklet. Define an isotope. You can skip that comfortably, all right? I know this is quite basic and dumb for me to say, but when I was in my A-levels, I did every single question repetitively, like as many times as I needed. So I would say skip over questions that you know how to solve and you know the answer to. There's no point of wasting your time with that. And for Isaac Physics, I think what you want to do when it comes to Isaac Physics is just allocate a little bit of time per week to just focus on that, maybe an hour a week, because Isaac Physics is not really for actually preparing for the exams and stuff like that. It's more so for problem solving skills. So I'd say put an hour a week into that. I think I'll talk more about Isaac Physics and problem solving in another video, but hopefully that makes sense. And the final thing you want to do, as you're going through these questions and as you're doing them, you want to modify your flashcards if needed. For example, let's say that you created your flashcard on strong nuclear force using these notes, but you didn't get all of the marks from the mark scheme when you checked your answer. when you answer the question in phase 4. So then you want to modify your answer to the flashcard so that you get the marks. But that's why I say you should look at exam questions first and the mark scheme before you make the flashcards so that you remember the information in the right way to get the marks. So basically, if you do step 3 properly and if you do this step here properly, then whenever you're doing questions in step 4, you will always be answering questions in the way to get the marks, right? And you'll notice that you get all the questions right pretty much the first time around. But if you do get something wrong, you can modify your flashcards if needed. And also, if there's something that you forgot to add, right, from the specification, right? Let's say you missed out on a key piece of information from there, and you notice that you were tested on this when you're doing the exam questions, and you basically realize, okay, like I need to remember this definition, or I need to remember this thing. Then you can create a flashcard on that after you finished going through the booklets, right? So hopefully that makes sense. That's basically it for A-level physics. Just to summarize, let's go back to the beginning. Step 1, time management. Remember this: 10%, 90%. Sort of understanding and application, right? Understanding is all about reading. I would say understanding, now that you understand like the 4-step process that we talked about, understanding is basically step 1, essentially. So understanding is only step 1, whereas application is steps 2, 3, 4. Okay. So steps 2, 3, and 4 is application, and step 1 is understanding. So you can see that you want to spend the vast majority of time on step 3 and 4. Actually, I would say that step 3 is sort of a weird one, because step 3 involves creating your Anki flashcards. So I would say that kind of could fall under here, right, when it comes to understanding, because as you're creating the flashcards, you're going to be consolidating your information. So you want to heavily prioritize doing questions from the textbooks and also the past paper questions. That's basically that's the application side. And then for understanding side, it's about understanding the material by reading the textbooks, watching YouTube videos, and also creating your flashcards, basically. So hopefully that makes sense. That's how your time split should sort of be, right? Make sure that you match the hours you spend in school with the hours you spend outside of school. And then when you have time for independent study, you use the 4-step process. Step 1 is about developing an initial understanding of the topic using these resources and the specification. Make sure that you don't take notes so that you completely focus your energy and time and attention on understanding what's going on. Then, once you've done that, you do as many questions as possible from the textbooks to deepen your understanding. You'll also do some fact recall questions where you can consolidate your understanding, and these will act as your notes. And you'll also get calculation and application practice when you're doing these sorts of questions here. Again, volume is very important in this phase, because the more questions you do, the more your understanding will be improved. And if you don't understand how to answer some question, you can just quickly research on ChatGPT. You know, I don't understand this thing. Why was this answered this way? And that will help you to improve your understanding of the whole topic, right? So remember, you might still make mistakes in step 2 in terms of answering the questions, but your understanding will be improved. Step 3 is about building your revision resources with Anki. I would say use these resources to get started. Make sure you use the exam questions to help you identify what information is needed to make your flashcards. And then step 4, just grind questions. That's basically it for the 4-step process there. So hopefully that makes sense, and hopefully that helped you out. If you are interested in getting into a STEM course at Top UK Uni, and you're in year 12 or year 10 or year 11, whatever, and you actually want to get into a top university, Oxbridge, Imperial, LSE, for a STEM course, something like natural sciences or engineering, then you should click the link in my bio to join my coaching program. These are the results that I've got recently for my students. You can see a lot of them are getting 100% in their further maths tests. And one of my students actually got an offer to study engineering at Cambridge down here. So that's pretty sick. So if you're interested in that, click the link in the bio to join. That's it for this video. Hopefully you found it useful, and I'll see you guys in the next one.